And we're live. Welcome, and good morning, afternoon, or night, depending on where you're joining us from. We're very excited to launch this series of live streams. Our goal is to explore the vast landscape of use cases for Prisma. We plan on hosting these live streams regularly, so be sure to tune in and check out. On Twitter, we'll be sharing some more streams. And today, Ryan D'Souza will talk about deploying a Prisma Client application with the Serverless Framework to AWS. Some of you may know Ryan from his developer success work on Slack and GitHub. Ryan is a developer success engineer at Prisma, and more broadly, Ryan is a full-stack developer focused on the JavaScript ecosystem. He loves contributing to open source projects and exploring the intersection between application development and the cloud with AWS. So now, without any further delay, I bring you Ryan. Ryan, you're
Thank you.
live.
Thank you very much, Daniel. So let's get started. So as Daniel has mentioned, the topic today is deploying a Prisma Client application with the Serverless Framework. So let's get started. So as Daniel has given a perfect introduction of me, I will continue with the next slide. So let's go to the topics for today. So first of all, we will give a brief introduction of what is serverless. Then we will see how Prisma Client works with serverless. What do we have to do? What steps have to be taken? And finally, we will do a hands-on demo of deploying Prisma Client to AWS Lambda. So let's get started. So what is serverless? So how is it different from our traditional servers? So suppose we have an EC2 instance or a DigitalOcean droplet. Serverless is not like that. You do not have to manage any servers yourself. You do not have to provide any auto-scaling rules or any other configuration. The provider does that for you automatically. So whenever you have lots of requests coming in, it will scale automatically based on the load. So that is the main difference. It's less configuration. So where serverless really shines, so there are lots of use cases for serverless. So the very easiest use case would be a one-off job, like a cron job or an email notification, anything of that sort, where you just fire and forget. So serverless is great for such use cases. Also, it is great when you have predictable workloads. Your workloads are predictable, and so you can save a lot of costs in that case. There is also a case where long-running servers would be preferable over serverless. Suppose you have lots of spikes every time, and serverless would then, in that case, become a bit more costly than a long-running server. In AWS, you have reserved instances which help you save costs. So in that case, a long-running server would be preferable. There are also some other cases where you require these, like sockets or sticky sessions, where long-running servers are easier. Although there are sockets introduced in serverless and API gateway, but I think it would be quite easy to configure it in a long-running server. So with the introduction out of the way, let's move on to what is a Lambda handler. So this is where we define a simple Lambda handler. The name of the function is handler itself, and it takes two parameters, event and context. It is returning a string here, a simple string hello world. So what does these two parameters do? The event parameter handles such cases like whether you have a response body from a post request or a single parameter that you want to take from the URL. And the context contains the information about the environment you're executing it. So in which operating system it's executing on. It'll also contain the CloudWatch logs, the logs that your Lambda handler is executing. So what happens when we call this function? So when this function is executed, AWS creates an environment for us in which this function will run. And then whatever is inside the function will be executed, and then the handler will be destroyed. But there's one thing to note here. What if we keep some context outside the handler? Suppose we have some objects outside the handler. What will AWS do to those? So AWS actually maintains those objects which are defined outside the handler, because when you have subsequent requests, those requests will be used, and the same object which is maintained by AWS will be used for that request. So this is actually maintained by AWS. We cannot configure it ourselves. So whatever's outside the handler will always be maintained when you have subsequent concurrent requests. So do keep this point in mind, as we will see how this is helpful to us when we are seeing our demo. Also, another point to note is cold starts. So Lambda suffers from cold starts in such a fashion that whenever there is a request coming in, AWS has to create the context, the environment for you, and then it will execute a function. So there is a bit of latency involved in that. So suppose if you do not require, or if you have a mission critical application that does not tolerate cold starts, then also in this case, a long running server would be helpful. So moving on to our next point. So how to make Prisma Client work with serverless. So I will have to show you a bit of code here. So as to how to make Prisma Client work with serverless. So let's check out our schema.prisma. So this is a simple schema. I am using a single model named user, and this will create a user table in our database. Similarly, our database is PostgreSQL, where I have provided the database URL with the environment variable. And to show you, the environment variable is configured in my env file. So you can configure this in any way that you want. This example env is in the repository. I have created two envs, one for development and one for production. So the final and most important part of making Prisma Client work with AWS Lambda is this part, the binary targets. So what are binary targets? So to go into this, let me explain to you how does the query engine of Prisma work. So this is straight from the documentation of Prisma. The Prisma client contains three parts actually. The first one is the JavaScript client library, the one that you use to query to the database. So what I'm writing my queries for. The second part is the TypeScript type definitions. So what do the TypeScript definitions do? It helps us write safer code and also give us autocomplete and IntelliSense of all the fields that are present in our database. Finally, the most important part is the query engine, which is a binary file that is an executable file. This binary file is generated whenever you run the Prisma generate command, and it creates the binary file in a folder. This binary file is specific to your platform. So if I'm using Windows, it will generate a binary file based on the Windows platform. Similarly, if I'm using Mac OS, it will generate one for the Mac OS platform. What does this binary file do actually in Prisma? So we have a diagram just for that. So whenever I create a connect function, whenever I connect to the Prisma client, the query engine creates a pool, a connection pool to the database. And after connecting, I execute my queries like find one or find many, which Prisma gives us. This will be converted by the query engine into equivalent SQL statements that will be executed on the database, and the response will be returned to us in the form of a JS object. Finally, when I run disconnect, the connection will be closed by the query engine. So this is basically how the query engine works. The main responsibilities of the query engine lie here. So back to our schema. We have two binary targets here. One is native and one is rel OpenSSL. I can show you those that are present in the node modules in the Prisma folder itself. So these are the two binaries which were downloaded. The Darwin one is for my local system, which is native. So whenever you specify the native function, it will always download depending upon your operating system. So Prisma will detect what operating system you have and will download the binary in that format. The other one is important though. Now we will be testing our environment locally, but in the end, eventually we need to deploy it on Lambda. AWS Lambda uses an environment, an operating system called Amazon Linux 2, which uses the rel OpenSSL binary. So it is different. It's a Linux environment. So we cannot use our own Windows, Mac OS binaries there. We would need to specify a specific binary called rel OpenSSL. And when we deploy our application on AWS Lambda, This binary will be used to query the database. So without this binary, we wouldn't have anything and our queries would fail. So this is how we integrate Prisma into AWS Lambda. This is the main part here. So without that, our configuration wouldn't work. So moving on, let's dive into the code. So now we will demo how we can deploy Prisma Client to AWS Lambda. Now I will be using the serverless framework here to make things easy. It's a very good framework and it will help me deploy the Lambda functions easily without much configuration. So let me walk you through the configuration. So this is our serverless.yaml file, and I've given a simple service name here, which you can name it to anything. So you can just clone this repo and configure it according to your needs. The other thing is the provider. So I'm using AWS here, and I'm using Node.js 12. Also, my region is US East 1. Another thing to note here, you should always create the database in the same region as you are deploying your serverless application to. The reason being that there is minimal latency and your queries will execute faster. So my database is also deployed in the same region, and it is using AWS RDS and is a Postgres database. We will talk about this function part later, but let's look at the plugins first. So first of all, I have Serverless Webpack. Serverless Webpack is a very handy plugin to bundle all your dependencies and deploy it to AWS Lambda. So that will help us when we are deploying. We also have Serverless Offline. This is another great plugin that we can use to mimic the Lambda environment on our system locally. So if I want to develop locally, I would not deploy every time whenever I make a change. I would need to see the changes that I've made and check it locally. So Serverless Offline is a great plugin for that. It automatically will reload whenever you make any changes. Finally, the serverless.env plugin. The serverless.env plugin is used where I have defined all my environment files. So these environment files that I've used will be read by this, and it will be added to the environment variables of AWS Lambda, which will be accessible there. So my next file will be the server file, the main server, which we have right here. So I'm using Apollo Server Lambda for this because I will be demoing with a simple GraphQL schema. But you can also use a simple REST API or anything else that suits your needs. So I've created a simple server here using Apollo Server, and I've created my handler here. This is the server.createHandler method, and I've exported this handler. Now you must be thinking that I've exported this, but where am I using it? That's where our functions call comes in. So this is the part in our serverless YAML, which will define what functions we will be using. Here we have simply exported a simple function named handler, and we are using this in the path here. We have provided the path. The path is src, the file name is server, and the name is handler. There are two events to note here. One is the post event and one is the get. The get one is for the GraphQL playground. And the GraphQL playground is where we will use and demo our queries and mutations, where I will show you how we can get our data from the database. And the post is simply for interacting with the GraphQL API, which you will use in your front end, for example, with Apollo client. Now, I had told you to remember a point. We can define things outside the handler, and they will be maintained by AWS on subsequent requests. So I will show you what is that about. I have created a new Prisma client here, which is actually outside the handler. Why have I done that? It is mainly due to performance reasons. So whenever Prisma client is initialized, it will create a pool of connections using the query engine. And whenever we have subsequent calls to our API, the same client will be reused again and again because it is defined outside the handler. This is also a performance improvement because we do not have to define Prisma client every time inside the handler. So this is the way you should always go with. Define your client outside the handler. And this is true for any configuration. Whatever is reusable should be defined outside the handler. So I have defined it here, and I have created my endpoint and my context. So this is a simple server configuration. Now let's look at the schema. Our schema is a simple Nexus schema. You can use an SDL based approach as well, but I have used Nexus because it is easier to create. So I have just created a simple user type here. So this is our user object, which we will be exposing to the client with the main endpoint. So I have exposed these three fields. And also I have created a query and a mutation. The query is to list the users, and the mutation is to create a user, which we will be seeing. Finally, I create the schema, which will automatically generate my schema.graphql file. And this is linked here to the server. So this is the basic setup that I am using. And let's see how we can run this locally and deploy it as well. So moving on to our file package.json. So you can see there are lots of scripts here, which we will go through. And also there are some dependencies. So Nexus, I'm using Prisma CLI and Prisma Client. For the Lambda, I'm using Apollo Server Lambda. Also, there are some other dependencies that are in the development dependencies specific to TypeScript and to Webpack. Now let's see how we can run this offline, how we can mimic the environment of AWS Lambda on our local system. So there is a command just for that, SLS offline. SLS is a shorthand for the serverless CLI, and on running SLS offline, it will run our basic environment here that we have created, and it will give us a local endpoint that we can use. So let's run that. So I just need to run yarn offline, and this will run serverless offline. It will bundle the dependencies with Webpack. It's also loading the environment variables. And here we have the endpoint. It's running on the default port of 3000. So let's check that out. So for simplicity's sake, I have already created a query. This will fetch us a list of users with their email and with their name. So let's hit that endpoint. So as you can see here, this is fetching the data, and here we have it. I have some pre-filled data here, and I get the list of users. Amazing. So this is exactly how a Lambda will work after being deployed to AWS. So whenever I make any changes to my server or to my schema, this will automatically reload, and you will get exactly what you want. It's like a live reload functionality you must have used with other servers before. So this is how we can run it in our local environment. Let me show you how we can deploy this to AWS Lambda. So I have created a script for that as well, named deploy. So what this does is that it sets our node env to production so that it takes the production environment file, and then we run SLS deploy. This command is again given to us by the serverless CLI, which will bundle all our dependencies with Webpack and deploy that, create an archive, a zip file of that, and then deploy it to AWS Lambda. So this is just a simple command, and let's run this and see what happens. So here I have run deploy, and it's running the SLS deploy function. And as you can see, it has taken my variables from the environment production. So it's using the database URL and the node environment from our production environment file. As you can see here, Webpack is bundling all the dependencies specific to my setup. So I have Prisma here, I have Apollo server here, and all the dependencies required to run the application. Finally, serverless will be packaging this service, and you will create a zip file that will be uploaded. For simplicity's sake, I have already deployed this to save time. So it is not changing anything, and so there are no changed files, and so it is skipping the deployment. But after deployment, you will see something like this. The service name, the development, which is our stage, the region, and in the end, you'll get a list of endpoints. So we have a get endpoint, which is for our playground, and the post endpoint, which we will be using in our client application. So this is done. Let's check out the final endpoint. Here it is. So this is our endpoint that we get from the serverless environment. And this is always whenever you deploy, the URL will remain the same. It will just get updated. So let's try the query again. And as you can see, I get the same users back because I've used the same database for development and production. Now you must have noticed that the response that I got locally was slower than the one that I got when I deployed. This is the exact reason that you need to keep the database in the same region as your deployment, serverless deployment. It is quite fast, as you can really see that I have deployed and it directly brings me the list quite simply. So let's try a mutation as well. Let's add a user. So this is my data. I already have user 1 and user 2. So let's add user 3. And here it's done. So let us again query for the list of users. Here we have it. So as you can see, this was quite fast. There was no latency, there's quite less latency involved, so to say, because both are in the same region. And I'm getting the data as expected. So this is how we can deploy our application quite easily with the serverless framework and the Prisma client. The main point to note here was exactly when we had our binary targets. You need to specify the binary targets for your AWS Lambda environment, otherwise it wouldn't work. The rest of the setup is simple because we have used the serverless framework. So going back to the slides, what shall we see as the end goal for us in this talk? So always instantiate Prisma client outside the handler. This will always help when you have subsequent requests. So the same client will be used again and again, which will be performant. Another point that I cannot stress enough is keeping the DB in the same region as your Lambda function to reduce latency. And as you saw, the difference between the local and the deployed version. Finally, always try to measure the costs before implementation. So there are lots of ways that you can measure whether the serverless environment is right for your needs. There are a lot of websites like servers.lol, a great name and a great website as well, where you can specify your environment and how, if serverless is really useful for your environment or whether a long-running instance would be effective. You also have sites like Serverless Cost Calculator, where you can calculate the cost of your serverless function by providing some basic values. It has costs for all the vendors, including AWS Lambda. So in the end, always measure whenever you're deploying something. Is my application right for serverless? Now, my application was a very simple application, and I think at most 10 to 20 users would be interacting with that. So serverless is great because AWS offers a free tier for serverless. Some amount of requests are free. So you will be practically paying nothing. So serverless would be a great choice there. So in the end, it's always good to measure and always good to see whether what environment is right for your needs. So the points that I mentioned, do keep them in mind. And that was all for my talk. So thank you very much. I hope you have taken something from this, have learned something from this. And hopefully we will be keeping another live stream where we can also say that how we can enhance this deployment by using AWS RDS proxy, which is like a load balancer for databases. And that would even make your experience much better and faster. So thank you, everyone.
Ryan, thank you so much for that.
Yep, thank you, Daniel.
That was really insightful, and we already had a couple of questions come in the audience. Let me.
Yep, sure.
I think the first one was from Asalio Diak. I'll display it on the screen, and he asked, "Is it possible to develop local with Apollo server from Apollo server Lambda?"
Sorry, I couldn't get you.
Rosalio asked if it's possible to develop locally with Apollo Server Lambda.
Yes, yes, it is possible. It's quite possible, and I'm using Apollo Server Lambda itself, and you can mimic the environment exactly locally using the serverless offline plugin. So if you check out the repo, which we will be sharing, so in that we have used serverless offline, which exactly does what Rosalio is asking for.
Okay, so essentially, is that part of the serverless plugin that simulates the Lambda environment locally on your machine?
Exactly.
Okay, got it. And then he had another question, which I tried to answer. But essentially, so the question is if we're using the API, the AWS API gateway, is that another event, or is the serverless YAML configuration file, is that the one that is responsible for also creating the API gateway?
Yep. So you're absolutely right, Daniel. The serverless YML file is responsible for creating the API gateway endpoints. So as we had seen, I had defined a snippet of functions. So those functions contained handlers, the get handler and the post handler. Those handlers will be created actually in API gateway when we run serverless deploy. So our Lambda function will be called by that endpoint, and that is how API gateway is connected to our Lambda function.
I see. Okay. And then Ryan Catalonia asked another question, which isn't directly related to your talk, but I'll take a stab at this. So he asked if the new distinct API is type safe. And so I wanted to clarify something. This is a new feature that we have in the newly released version of Prisma Client, and the way that it works, distinct works, is it simply acts as a filter. So the return type when you call the distinct API is exactly the same as it is for find many, and in fact you can use that together with include or select if you want to fetch also relations of whatever you're trying to get the distinct of. And we already have more questions coming in. Okay. Do you want to take this one, Ryan?
Yep. So Nexus plugin Prisma, you can use that absolutely, but it comes with Prisma CLI and Prisma Client bundled. So I have yet to try that in deployment, but I think it should work fine out of the box. If you're using Nexus plugin Prisma, then yes, you will be bundled with Prisma Client and Prisma CLI out of the box. So you can go ahead with that, use that as well. It won't make any difference to your development experience.
Thank you, Ryan. We have more questions coming in. Another one from Roselio. Roselio is really active today. Thank you.
Yep.
So can you see the question? You recommended earlier using a long-running server for subscription. Do you have any experience with API Gateway?
So with API Gateway, I have created a basic WebSocket subscription. It was just a demo, and I do not have an experience of that in production. But I usually prefer long-running servers because they are easy to set up for me, while specifically for subscriptions, as they usually keep the context and everything intact. But I think API Gateway would be a great one too. But in the end, you have to measure the costs, like how long your subscriptions are going to last, how many hits you're going to get. So you have to take in the cost factor as well, and then decide whether you want to go with API Gateway. But it's perfectly fine to use that as well. No issues.
I see. And by subscriptions here, does it be good if, do you mean GraphQL subscriptions? Is that the question?
Yes, GraphQL subscriptions in turn would use WebSockets itself under the hood. So I would say yes, that would work well.
Okay, and now we have a question from Dixita. Hello, Dixita. Thank you for the question. Can the same be followed for Google Cloud Functions or other providers?
Yes, exactly. So serverless YAML file that is based on this, that is due to the serverless framework that we have, and that supports Google Cloud as well as Azure. I don't know of any other environments, but these two are the most famous along with AWS. So yes, you can follow the same in other environments. You just have to note that whatever operating system they are using for serverless under the hood, you need to generate the Prisma client binary for that. That is the only thing that you need to take note of.
Okay, so making sure, checking which runtime operating system they're using, and accordingly finding the one. Okay, and we have a question
Yep.
specific to that from Rushi, I believe the name is. Does anyone have problems with deployment when using rel OpenSSL? My terminal just hangs using Windows. Do you have any thoughts on that, Ryan?
Um, Unfortunately, I haven't faced such an issue. It might be Windows specific, but I would have to reproduce that and check because on other systems, I haven't faced that issue.
Okay, so Rushi, you can open up an issue and leave as many details as possible so that we can reproduce this and then test it. We
Yep.
obviously have also a focus on supporting Windows, and this is obviously part of what we do.
Yep.
Okay, and I also had we had another question. Yeah, okay. So Sachin said that he would love to see a talk that covers the use of AWS CDK that abstracts away setting up things manually in AWS. So thank you for that feedback. We'll take that in and we'll see what we can do there. And I also had another question with regards to deploying using the serverless framework. So in general, what are some of the benefits of using the serverless framework over, say, a vanilla AWS approach? And do you have any experience with other approaches of deploying to AWS?
Yep. So I have both. I have experience with both the vanilla deployment approach and the serverless framework as well. So in the vanilla deployment approach, what you would have to do is that you would have to create your setup. That is what I've created with the Prisma client. You would have to bundle it by yourself, like create a zip file and then upload it to AWS Lambda manually, which is not a good experience at all because it neither provides you local experience, you cannot debug it locally. You have to always upload it before checking the output, and you have to always upload a zip file because whenever a specific deployment gets greater than a certain threshold of size, you have to create a zip file and deploy it to Lambda. And I'm sure that's true for other serverless environments as well. What the serverless framework does is that it abstracts all of this for us using AWS's own service called CloudFormation. What it does that it creates a CloudFormation template, which is great, which is also known as infrastructure as code. If people have heard the term for that, it's a buzzword nowadays. They're using it a lot. So it creates an entire template of your application. What will be the Lambda function? What will be the API gateway that will access the Lambda function? Where are you deploying it? What will be the connections? What will be the function names? You just have to specify that in a simple YAML file and it will do the rest for you. It also has third-party plugins as we explored today, like Serverless Offline, and we also have Serverless Webpack for packaging our backend applications. So in all, it provides such a great experience that you wouldn't want to go back to manual deployments again. So if you're a beginner, if you just want to learn how it works, then you can deploy it manually. But for production, I would recommend using the serverless framework.
I see. Okay, well, thank you so much for that, Ryan. Do you have any other things you want to share, any notes before we wrap up?
Nothing, just from my end. I hope that you enjoyed the talk, and I hope that we will come back with the live stream soon regarding other practices to use in serverless, like I mentioned, especially with AWS RDS proxy, which has been recently introduced. So that will be a great thing to explore as well.
And this AWS feature that you described, the RDS proxy, is that essentially a connection puller?
Yep. So you might be familiar with other connection poolers like PG Bouncer. So what they do is that they create a connection pool of your database and reuse that same pool, which helps a lot. It's like a load balancer for your database. It uses the pools efficiently and it doesn't have a great memory impact. So your connections to the database don't get exhausted. It's a great way to handle database connections in production.
Great. Well, Thank you so much, Ryan. And I've got some wrap up notes that I want to share. So we have some more upcoming streams, and Ryan just mentioned the follow up stream that he will give, talking more about other aspects of serverless and AWS. We also have announced today version 2.30 of Prisma Client, and some of the exciting features that are part of that release are first of all, we have a new version of the VS Code extension, which really helps with when you're working with the Prisma schema. There's a new rename helper tool, which makes changing model names a lot easier. Besides that, we had the new distinct API, which essentially maps to the select distinct of SQL. So that allows you to select distinct values. And lastly, we have the middlewares API. This API essentially allows you to hook into the control flow of Prisma Client and do all sorts of things such as query benchmarking, and it's heavily inspired by the way that Koa does this. Koa.js being the Node.js framework. And then lastly, we already have another stream scheduled for next week, which I will be hosting. And the focus of that stream is it'll be the first stream of a series of streams covering building modern backends with Node.js. And next week's stream will focus on data modeling with Prisma Schema, doing CRUD operations and aggregations with Prisma. And what we're going to do is we're going to actually look at a real world problem with this. So I'm sure that some of you are already a bit tired of seeing the examples with a blog and a user in a blog, as we often do. So this is a great opportunity, to look at some of the, some of the challenges that arise when you're actually building a real-world application. So that's it for us. We thank you so much for joining us today, and we hope you enjoyed it. If you have any feedback, feel free to reach out. We also have the public Slack channel, which you can join and engage a bit with the Prisma community. The address for that is slack.prisma.io, in case you're not already there. And having said that, I wish you a nice evening, a nice rest of the day, and thank you again, Ryan.
Yep. Thank you, Daniel. Thank